A beam of uniform section is built in at each end so as to have a clear span of 6 meters. It carries a UDL of 25 kilonewton per meter on left half of the span and point load of 120 kilonewton meter, 120 kilonewton, 4.5 meters from the left end. Find the reactions and fixing moments at the ends and draw the bending moment diagram. Here he has given one fixed beam which is of 6 meters span. Here you are considering a fixed beam which is of 6 meters span. Is the whiteboard is visible? Why is whiteboard is visible? Yes, sir. So here you are considering a 6 meters and here it is, and he has given it is carrying a UDL of 25 kilonewton per meter on the left half of the span. It is carrying a 25 kilonewton per meter on the left, UDL of 25 kilonewton per meter on the left half of the span is 3 meters, and it is carrying a load of how much? It is carrying a load of 120 kilonewton, 4.5 meters
4.5 meters
from the left end.
from the left end.
120 kilonewtons.
3
meters. This one is 1.5. Total it is. Meters. Understand? So he has given like this. He has given a fixed beam. So here you have to calculate, find the reactions and fixing moments at the ends and draw the bending moment diagram. In the previous problems, directly you have considered the fixing moments MA and B, free bending moment, free moments MA and MB, and you have calculated the support reactions and moments, and then you have drawn a shear force and bending moment diagram. Here you are going for a different procedure. You are considering a bending equation. It is the deflection equation. Here you are considering. Using the deflection equation, here you are going to solve the problem. Using the deflection equation, we are going to solve the problem. Here I am considering a section X. Here I am considering, when you see this diagram here, when you draw the line diagram, here you have a reaction. Here it is VA, VB. Here you have UDL, point load. Here it is 25, and also you have a external moment, that is moment MA and MB. MA is acting in this direction and MB is acting in opposite direction. Understand? You have MA and MB. You have MA and MB. Then here you are considering the section X. Why you are considering the section X here? Here you are considering the section X. Why? Because here you have a UDL which is fixed at a left end support. You have a UDL up to the left end, so you are considering towards the left end. You are considering the section towards a left end. So you are considering the section towards a left end. So here you are, the deflection equation is, your deflection equation is EI d square y by dx square is equal to mx. Understand? Using this differential equation, here you are going to solve this problem. Okay. So Here this distance is 3 meters. The distance is 3 meters, 1.5, 1.5. When you calculate the moment, what happens? Mx. When you calculate mx, moment about x, it is Vb into x meters. When you calculate the moment, here you have a Vb at this point, Vb into x meters. Then you have 120 into, here you have 120 into x minus 1.5. This distance you will calculate. This distance you will calculate. This distance you will calculate. Vb into x meters. Vb into x meters. Then 120 into this distance. This distance is x minus 1.5. Then another one is UDL, that is 25 into this remaining distance. 25 into x minus 3 into x minus 3 by 2, and you have external moment mb. Here you have this value also. It is acting in which direction? It is acting in a clockwise direction. It is acting in clockwise direction. When you see here the problem, here it is Vb into x minus mb. Vb into x is acting in a anti-clockwise direction. From the right side, anti-clockwise is positive. From the right side, anti-clockwise is positive. From the right side, the anti-clockwise will be positive. So you are considering it like this: Vb into x minus, here is Vb into x meters. From here the distance is, here you are considering the section x. Vb into x, 120 into this distance. This distance is x minus 1.5. 120 into x minus 1.5. This distance will be 25 into x minus 3 into x minus 3 by 2. Understand? Are you able to understand? Everybody is able to understand. Here you are considering the reflection equation EI d square y by dx square is equal to mx. Okay, from this differential equation, writing like this. Here you are considering the differential equation EI d square y by dx square is equal to mx, where mx is this value Vb into, ఇమా అర్థమవుతుందా? ఈ ఈక్వేషన్ అర్థమైందా ఎలా రాసామో? ఇమా ఎవ్రీబడి, ఇమా ఎవరో ఒకరు ఆన్సర్ చేయండి. ఓకే, నెక్స్ట్ you will move it upwards. Then here you are integrating this equation, or integrating this one. Here you have a Vb into x minus mb, then you have minus 20 into x minus 1.5, then you have minus 25 into x minus 3 whole square, x minus 3 whole square by 2, x minus 3 into x minus 3 by 2, that one will be x minus 2 whole square by 2. Then we'll integrate on both sides. When you integrate it, here the equation is ei d square y by dx square is equal to Vb into x minus mb minus 120 into x minus 1.5 minus 25 into x minus 3 whole square by 2. If you integrate it, what happens? It will become ei dy by dx. When you see here, ei dy by dx, here vb into x will become, when you integrate it, here vb into x will become, when you integrate it, here ei d square dy by dx, it will become, metal vb into x will become vb into x square by 2 mb into x minus 120 into, this one will be 120 into x minus 1.5 by 0.5 whole square by 2. When you integrate it, 2 will here, it will be cancelled, you get 60 here. Here you get 25 into x minus 3 whole cube by 3. 2 into 3, it will become a 6. Ima, ఈ సెకండ్ ఈక్వేషన్ అర్థమైందా? మా
Yes, sir.
సెకండ్ ఈక్వేషన్ అర్థమైంది కదా?
అర్థమైంది సార్.
Okay, next we will go to the next equation. So next we will jump to here. After getting this one, okay, again substituting the boundary conditions. Here the boundary conditions are, substituting the boundary conditions, at x is equal to 0, dy by dx is equal to 0. Then this equation will become, at x is equal to 0, dy by dx equal to 0. If you substitute here, dy by dx 0, 0, m minus mb into 0, 60 into 0 minus 1.5 whole square, 25 into this equation. Okay, I'm explaining this equation. When you substitute here, okay, when you substitute in this equation, when x is equal to 0, dy by dx is equal to 0, you will get a c1 is equal to 0. When you substitute the other boundary conditions, that is, the other boundary condition is, at x is equal to 6, dy by dx is equal to 0, you will get this equation. When you substitute at x is equal to 6, dy by dx is equal to 0, the equation will become, here it will be 0 equal to vb into 6 square by 2 minus mb into 6 plus c1. c1 is already 0, you will substitute it, minus 60 into 6 minus 1.5 minus 25 into 25 by 6 into 6 minus 3 whole square. When you substitute it and simplify it, you will get this equation, 18 vb minus 6 mb minus 1215 is equal to 112.5. You will get the equation as this equation. Then 18 vb minus 6 mb is equal to 1327.5. Up to here it is clear. Just you have considered the deflection equation, ei d square y by dx square is equal to mx. You have substituted the value of mx, then you have integrated, then you have substituted the boundary condition, at x is equal to 0, dy by dx is equal to 0, at x is equal to 6, dy by dx equal to 0. Here we will get one equation. After that, again you are integrating the above equation. You are integrating, again you are integrating the above equation. The above equation is this one. You are integrating this equation ei d square dy by dx integrated, you will get ei y is equal to vb into, you are integrating this equation vb into x cube by 6 minus mb into x square by 2 plus c1. You will get the equation like this. You will get the equation as ei y is equal to vb into x cube by 6 minus mb into x square by 2 minus plus c1x minus 60 into x minus 60 into x minus 1.5 by 5 whole cube by 3. Here you have minus 25 into x minus 3, 25 into x minus 3 whole to the power of 4 by 4, that is 25 by 24. Here you will get. Okay, this one will be the equation eiy is equal to, the equation will be this equation you will get. Okay, vb into x cube by 6 minus mb into x square by 2 plus c2 minus 20 into x minus 1.5 whole cube minus 25 by 24 into x minus 3 whole to the power of 4. c1 is already 0, you have substituted c1 into x, you have substituted 0 into x, that is the value, plus c2 we have. Again you are applying the boundary conditions at x is equal to 0, y is equal to 0, this boundary condition, then c2 will become 0. Understand? ima ardhamautunda? ima evaro okaru answer cheyandi, ardhamautunda? Okay, next here you are substituting other boundary condition at x is equal to 6, y is equal to 0. What happens? 0 into vb into 6 cube by 6 minus mb into 6 square by 2. Here in this equation you are substituting c2 into c2 minus 20 into 6 minus 1.5 whole cube, 25 into 24 into x minus 3 whole to the power of 4. Here after substituting it, when you simplify this one, you will get this equation. I will send this document to you afterwards. Just listen here. This will be your equation. After getting these two equations, for solving equation 1 and equation 2, you will get a values of VB and MB. ఈ రెండు ఈక్వేషన్స్ ని మనం సాల్వ్ చేస్తే you get the values of VB and MB. After that, you are calculating the support reactions. Here you are applying. Mute. Okay, after that, here you have, so you are solving these two equations, you will get a two values VB and MB. You get a two values VB and MB. Get two values VB and MB. After that, here you are calculating upward forces is equal to downward forces. What are the total loads here? The total loads are, vertical loads are VA plus VB is equal to 120 plus 25 into 3. These are the total loads here you have. VA plus VB is equal to 25 into 3 plus 120, it is 195. VA is equal to 195 minus 15. Here you will get a value of VA. You have calculated the value of VA and VB. Then you will calculate the value of MA. Here we are calculating moment about A. Understand? You know the value of mb, you will calculate moment about A. When you go to the diagram, you are calculating moment about A. From this diagram, you can see here, when I am writing moment about A, what is the value of moment about A here? When you are calculating moment about A, VB into 6 meters minus 120 into 4.5, 120 into 4.5 minus 25 into, here you have 25 into 3 will be the force, 3 by 2 will be the distance, minus mb. Understand? Substitute all these values, you will get a value of moment about A. Here he is calculating 115.31, that is VB into 6 minus 124.66 minus MB minus 120 into 4.5, 25 into 3 square by 2. Understand? అర్థమవుతుందా? Okay, next we will go to the next point, that is fixing moments. You have a two moments and two reactions. Already you have calculated two moments and two reactions. Rendu reactions, rendu moments calculate chesamu. Here you have calculated two moments and two reactions. These are the values you have. Two moments and two reactions, MA and MB. Then you are calculating bending moment at A, at C and at D. Okay, when you go to diagram here, your diagram lo ganake velte, here you will get a bending moment at A. Already you have a value. You have to calculate bending moment at C. C దగ్గర calculate చేయాలంటే either you can calculate from the left side or a right side. Okay, when you see the diagram here, when you calculate bending moment at C, that is MC. Okay, if I am calculating from the left side, here you have minus MA, then you have my plus VA into 3 meters minus 25 into 3 into 3 by 2. You'll get a moment about C. Next, if you calculate moment about D, I will calculate from the right side. The value is minus MB plus VB into 1.5. This one will be moment about D, as written here. You can see. Okay, and minus MB, VB, this one will be 79.6875 into 3, VB into 3 minus 25 into 3 square by VA into 3, this one moment about C, VA into 3 minus 25 into 3 square by 2, here you have minus MA. Then here you have bending moment at D, this is VB into 1.5 minus MB. After that, we'll calculate the point of contraflexure. Understand? The point of contraflexure is the point where the bending moment is 0. For that one, you need to draw the bending moment diagram. దానికోసం ఏంటంటే you have to draw the bending moment diagram. How will you draw the bending moment diagram here? Okay, you know the value of MA, MC and MD. Okay, you know the value of bending moment about A, C and D. So I will show you how to draw the bending moments. We'll show here, else we'll go to the diagram. Here you can draw the bending moment diagram. So I've drawn the line to this one. Here the moment about A is negative value, minus 85 find something. Then moment about C, you need to know the value of moment about C is 41.25. Moment about C is 41.25. Next, moment about D is 48.28. Moment about D is 48.28, somewhere here. Then moment about B is, it is also a negative value, 124.687. It is also a negative value, 124.687. When you draw here A to C you have an UDL. It will be a parabolic curve. Then from C to D it is linear. From D to C again it is linear. The curve will be like this. This is the bending moment diagram. Different points. When you see the diagram will looks like this. Understand? అర్థమైందా? The diagram will looks like this. Then we'll calculate the point of contraflexure. Point of contraflexure means the point where the bending moment is 0. That means here you can calculate the contour of contraflexure. The point where the bending moment is 0. That means at this point the moment is 0. So here you are calculating moment about x. That is at this point you will calculate 85.3125 into x. Here you have uniformly distributed load, 25 into x into x by 2 is given the same, and I have an external moment 85 point. Here it is 8, here it is 85 point. So here you have 80 point. This one is VA value. VA value is 79.687 into x. 25 is a UDL, 25 into x square by 2 minus here you have a MB value 85.312. Simplify this one, you will get a point of contraflexure, that is 1.36. You can calculate from the left hand as well. When you calculate from the right hand, here it will be VB. VB value is 115.312 into x. Here he has given 115.31 into x, 3125 into x minus 124 is MB. Okay, here also you will get an x value. Okay, in this way you draw the bending moment diagram for this problem. అర్థమవుతుందా? If you want you can calculate shear force as well, but in this question he has only asked the bending moment diagram. In the next problem he has asked both shear force and bending moment diagram. Do you have any doubts in this problem? ఎవరికి ఏమైనా డౌట్స్ ఉన్నాయా? Here this is the first we have calculated, just I am repeating once again, just listen it carefully. Here we have considering the section x. Here you have a UDL, so here you are considering the section x at the left end. Then you have considering the bending equation EI d square y by dx square is equal to mx. You are calculating moment about x. Then after that you are integrating on both sides. Then after that you are substituting the boundary conditions. At x is equal to 0, dy by dx is equal to 0, you will get C1 as a 0, then you are substituting at x is equal to 6, dy by dx is equal to 0, then you will get one equation. Then again you will integrate this dy by dx equation again, then it will get eiy is equal to this equation. After that you are substituting the boundary condition at x is equal to 0, y is equal to 0, get c2 is equal to 0. After that you are substituting second boundary condition at x is equal to 6, y is equal to 0, you will get another equation. You are solving equation 1 and 2, you will get the values of vb and mb. After getting these values, calculating another support reaction, that is Va, using upward forces is equal to downward forces, that is sigma Fy is equal to 0, using the equilibrium equation. Then here you will get a value of Va. After that, then calculating bending moment at A. So you know the value of Mb, you are calculating the value of Ma. Okay, here you will get a value of Ma. After that, you will get a values of both fixing moments. After that, you are calculating moment about A, you are calculating moment about C, moment about D. Then you are drawing the bending moment diagram. After drawing this one, you are calculating the point of contraflexure, the point where the bending moment is 0. After that, calculating point of contraflexure, the point where the bending moment is 0. Understand? మా ఇందులో ఏమైనా డౌట్స్ ఉన్నాయా? If you have any doubts, you can ask. ఇమా మీ మైక్ని అన్మ్యూట్ చేసి అడగండి ఏమైనా డౌట్స్ ఉంటే. Or you can raise your hand. Okay, I will again explain the point of contraflexure again. Okay, ఎవరు అడిగారు? Roll number 23. Okay. We'll explain the point of contraflexure. So the point of contraflexure is nothing but a point where the bending moment is 0. Point where the bending moment is 0. Here how will you calculate means, when you see here you have VB untadi, here you have an external moment in anti-clockwise direction AMA, and here you have a uniformly distributed load 25. So the simple equation is VB into X. The simple equation you will consider is VB into X. Simple equation you will consider it is, I am writing here, VB into X. No, this is not VB, VA. VA is VA. VA into X. VA into X minus MA minus MA minus 25 into X square by 2. 25 into X square by 2 equal to 0. దీన్ని కనుక మనం సింప్లిఫై చేస్తే అదే ఈక్వేషన్ ఇక్కడ రాశాడు. VA value is, when you see here VA value is 79 point, here you have an equation, VA value is 79.687 into X minus UDL is 25 into X square by 2 minus MA value is 85.3125. దీన్ని సింప్లిఫై చేస్తే X value 1.361 meters వస్తుంది. సిమిలర్లీ మనము లెఫ్ట్ సైడ్ నుంచి రైట్ సైడ్ నుంచి క్యాలిక్యులేట్ చేయాలంటే, హియర్ యూ హ్యావ్ ఏ సపోర్ట్ రియాక్షన్. You want to calculate from the right side. You want to calculate from the right side. You have a support reaction VB and the moment is acting in a clockwise direction, that is MB. Okay, when you calculate up to here, you have a point of contraflexure. So the equation will be VB into x minus mb equal to 0. B into x minus mb equal to 0. This is 115.31 is VB. This is the value of VB and this is the value of MB. Simplify it, you will get the value of x. Understand? ఏమా ఇంకా ఎవరికైనా డౌట్స్ ఉన్నాయి ఇందులో ఈ ప్రాబ్లంలో? ఏమా is it clear? Anybody has any doubts? Okay, can I go to another problem? ఏమా మాట్లాడండి, ఎవరు మాట్లాడట్లేదు ఏంటి? Okay, next we are going to the next problem. Okay, see here he has given another problem with a fixed beam with the UDL throughout the beam, and it has given a point load as well. Point load and external couple also. External couple force or external moment force is also he has given. External moment force as well here is given. External moment as well. So in this one he has given external moment. Okay, in this problem, when you see this problem, you have only another 20 minutes. Okay, again I have a first year class. So here he has given a problem. A beam of uniform section is positioned in direction fixed at both ends of a span of 8 meters. Here he has given a beam with a span of 8 meters. We'll read the question and draw the diagram. A beam of uniform, if you won't give the diagram, he has given question directly. A beam of uniform section is positioned in direction fixed at both ends of a span of 8 meters. He has given a beam, fixed beam with a span of 8 meters. At a point 5 meters from the left end, a connection made to the beam exerts a vertical downward force of 80 kilonewtons. At a distance of 5 meters from the left end, here you have the point load of 80 kilonewtons. Here you have a point load of 80 kilonewtons, and also he has given clockwise couple of 60 kilonewton meter in the vertical plane of a bending. Here it is, the clockwise couple is acting. How much it is? 60 kilonewtons. The clockwise couple is 60 kilonewton meter in the vertical. The beam carries a uniformly distributed load of 7.5 kilonewton per meter on the whole span. The beam is carrying an UDL of 7.5 kilonewton per meter to the whole span. Determine the reactions and moments and the supports and draw shear force and bending moment diagrams. Okay. So first you have to calculate the reactions and moments. Then you have to draw the shear force and bending moment diagram. Understand? Then you have to draw the shear force and bending moment diagrams. You understand? Okay. Then we'll go to the problem. So here he has given this problem. Here you can consider the section either left end or a right end. Now I am considering the section at a right end. I am considering the section at a right end. So I am considering the section here as x, and the bending equation is ei d square y by dx square is equal to mx. This is the equation you are considering. The bending equation you are considering is ei d square y by dx square is equal to mx. This is equation you are considering. Bending equation is ei d square y by dx square is equal to mx.
Good morning, sir.
Good morning.
Morning.
The class తొందరగా స్టార్ట్ సరే
ఏమా ఇది సెకండ్ ఇయర్ క్లాసు, మీరు ఎగ్జిట్ అవ్వండి, 8 o'clockకి జాయిన్ అవుదు కానీ. ఏమా ఇది సెకండ్ ఇయర్ స్టూడెంట్స్ క్లాసు. ఓకే, సీ హియర్. So I am considering here so ఇక్కడ మనం చూస్తే కనుక I am considering a section here. Then when I consider section here VA into x minus MA, here you have a VA into x meters minus MA. It is acting in a anti-clockwise direction. Minus MA, here you have minus 7.5 into x meters, 7.5 into x by x into x by 2 is the UDL. So here it is 7.5 into x into x by 2. Then here you have 80 into x minus 5. Then you have 60 into x minus 5. Then you have 60 into x minus 5. This is 60 meters. The remaining distance is 60 into x minus 5. Then you are integrating on both sides. This one will become ei dy by dx is equal to va x square by 2 minus ma into x minus 1.25 into x cube plus c1 into plus c1 minus 40 into x minus 5 whole square by 2. 80 into x minus 5 whole square by 2. Here 2 into 40 you have cancelled with respect to 80. Then here it is 60 into x minus 5. ఏమా ఇక్కడ మీరు చూస్తే కనుక 60 is a external moment. దీన్ని ఎలా రాశాడు ఇతను, 60నే రాయాలి డైరెక్ట్గా. అయితే హియర్ హీ హ్యాస్ రిటర్న్ ఇట్ ఈస్ యాక్టింగ్ ఎట్ x minus 5 distance. 60 into x minus 5 whole to the power of 0 అని రాశాడు. ఓకే, here he has written it as 60 into x minus 5 whole to the power of 0. 60 into x minus 5 whole to the power of 0. Here he has written it as 60 into x minus 5. ఇక్కడ చూస్తే కనుక మీరు when you see here he has written it as 60 into x minus 5 whole to the power of 0. He has written it as 60 into x minus 5 whole to the power of 0. Understand? Next, when I integrate again, here I am substituting the same boundary conditions whatever I have substituted before. At x is equal to 0, dy by dx is equal to 0, then c1 will become 0. At x is equal to 8, dy by dx is equal to 0, you will get one equation. ఇక్కడ ఒక ఈక్వేషన్ వస్తుంది. ఓకే, సింప్లిఫై చేస్తే you will get this equation. Similarly again I will integrate it and substitute the boundary conditions. At x is equal to 0, y is equal to 0, you'll get C2 0. At x is equal to 8, y is equal to 0, you'll get another equation. I will solve those two equations. ఈ రెండు equations ని నేను solve చేస్తే you get a value of MA and VA. After that, you're calculating upward forces is equal to downward forces. Sigma Fi is equal to 0 వేసి calculate చేస్తే you get a value of VB. Understand? ఏమో అర్థమైందా? సేమ్ ప్రాసెస్ ప్రీవియస్ ప్రాబ్లం ఎలా చేసామో సేమ్ అలాగే చేస్తాం. Understand? After that, you are calculating the MB. MB means moment about B. When you are calculating moment about B, VA into total 8 meters, 7.5 into, see here, I'm explaining here. So when I am calculating here, VA into this total 8 meters, 7.5 into 8 into 8 by 2, 80 into 3, 80 into 3, then it is acting in a clockwise direction. From right side, clockwise is positive, plus 60. Okay, this is the value here, plus 60. VA into 8 meters, 7.5 into 8 into 8 by 2. Here it is MA minus MA is 76.62. Here it is 80 into 3 plus MB is equal to 0. You will get a value of MB. After this, you will calculate the forces. Force at A is SFD calculations. You will calculate. You will calculate shear force calculations. Force at A is, when you see here, force at A is 44.776. Understand? ఏమో అర్థమవుతుందా? మా same process, the remaining problem I am calculating here, the shear force calculations. Force at A is 4.77. Then you have force at C left. Left calculate చేస్తాం కాబట్టి 7.5 into 5 will be the force at C left. Then force at C right is, that is force at C is 7.22, the upward force plus this 80. Then shear force at B is the remaining force. B దగ్గర ఏముంది మీకు ఇక్కడ? UDL is there. Again you have a UDL, shear force at B. Before B you have a UDL, that is 1.5 into 3 meters plus the upward force యాడ్ చేస్తే మీకు ఇక్కడ రావాల్సింది ఏంటి? VB ఎంత ఉందో అంత వాల్యూ వస్తుంది. The value of VB here it is 95.234. Here also you will get, ఇక్కడ ఏం చేస్తామంటే 7.5 into 3 minus the remaining force is 72.734. చేస్తే you will get this value. Understand? అర్థమవుతుందా? Are you able to understand? ఇది కూడా negative value. Why? Because it is downward force 7.5 into 3 minus the upward force is 72.73. Totally you will get this value. You will get a shear force. When you draw the diagram here, when you draw the diagram, I am considering here it has a positive value. Here it has 7.266 kilonewtons. This value, then negative value minus 7.72.734. Here you have a negative value 95.23. Here UDL is acting, so I am drawing linear, coming down and drawing linear. Understand? ఏమో అర్థమైందా? Is it clear? Is it clear? Okay, next we will go to Bmd calculations. When you go to Bmd calculations, you have a moment about A, moment about B. Then you will give it moment about C. Moment about C దగ్గరకు వస్తే మీకు you have a external moment. When you go to moment about C, moment about C, when you go to moment about C, when you go to moment about C, you have an external moment here. మీరు moment about C దగ్గరికి వెళ్తే కనుక మీకు external moment ఉంది. Here you have external moment. At this point, the moment about, you have to calculate C left. Left ఒకటి calculate చేస్తాం, moment about C calculate. Moment about C left అంటే VA into 5 meters. ఇక్కడ మీకు చూపిస్తాను. Here it is. VA is 44.766 into 5 meters. VA into 5 minus MA. తర్వాత this one is 7.5 into 5 into 5 by 2. That is UDL. ఇక్కడ మనకి UDL యాక్ట్ అవుతుంది కదా. 7.5 into 5 into 5 by 2. That is up to here. You have moment about C. External moment యాక్ట్ అయినప్పుడు C left C తీసుకుంటాం. C left అయిన తర్వాత C is nothing but how much load it is acting here. ఇక్కడ ఎంత లోడ్ యాక్ట్ అవుతుంది? Couple force is 60. It is acting in clockwise direction, so here you will add plus 60. Understand? Then you will draw the diagram here, the bending moment diagram. Here the value of 76 moment about A is MA is how much? 76.56. I have taken one point here, 76.56. Next here it is this value which we have calculated at left hand. It is 53.517. Here the value is 53.517. The next value is 113.513. There at C only. C దగ్గరే యాక్ట్ అవుతుంది. Next here it is minus 138.44. Will join. UDL is acting, so it is parabolic. It will go up. Again UDL is acting, it is parabolic. Understand? It will go up. Okay, in this way you have to draw the bending moment diagram. Okay, point of contraflexure మీరు calculate చేయండి. Already he has given a point of contraflexure, the point where the bending moment is 0. Here you have a point of contraflexure. So point of contraflexure, here you have VA into x meters minus MA in minus 77.5 into x by 2. Here point of contraflexure which is VA is 44 point. Here he has given a 44.766 into x minus MA minus 7.5 into x square by 2. That is 3.75. You will get a point of contraflexure. Similarly, from the left end నుంచి calculate చేస్తే మీరు here VB into x minus MB, then 7.5 into x by 2. VB into x, this is VB minus MB minus 7.5 into x square by 2. You will get as 1.54. Understand? In this way you have to solve this problem. Okay, ఏమైనా డౌట్ ఉందా? ఈ డాక్యుమెంట్ నేను మీకు షేర్ చేస్తాను. ఓకే, కొంతమంది వాట్సాప్ నెంబర్స్ ఉన్నాయి, అందులో పంపిస్తాను. వాళ్ళు ఏంటంటే మీ ఫ్రెండ్స్కి షేర్ చేయండి అవి. ఓకే, okay, if these two problems are completed, then you have completed fixed beams. You have completed continuous beams and fixed beams. And tomorrow I'm going to start another topic. Understand? రేపు ఇంకొక టాపిక్ స్టార్ట్ చేస్తాను. ఏమా మీకు ఏమైనా డౌట్స్ ఉన్నాయా? ఏమా ఎవరెవరు వచ్చారో కొద్దిగా అటెండెన్స్ చెప్పండి మీరు. ఏమా టోటల్ 39 మెంబర్స్ అటెండ్ అయ్యారు. మీ మైక్ ఆన్ చేసి Roll number 1.
Roll number 1.
Roll number 2. ఏమా మీ చాట్ మెసేజ్లో ఎస్ అని పెట్టినా లేదు. రోల్ నెంబర్ 2.
Roll number 2.
రోల్ నెంబర్ 2.
Number 2.
మా తొందరగా.
తొందరగా.
నెంబర్ 3. సార్ 4.
Yes, sir.
Yes, sir.
చేస్తాను. మీ నేమ్స్ అన్నీ ఉన్నాయి కదా.
మీ నేమ్స్ అన్నీ ఉన్నాయి కదా.
సిఆర్కి మెసేజ్ చేయండి ఎవరెవరు అటెండ్ అయ్యారు. నేమ్స్ అన్ని నేను తీసుకుంటాను.
నేమ్స్ అన్ని నేను తీసుకుంటాను.
టుమారో యూ హావ్ ద క్లాస్ ఎట్ ద సేమ్.
Tomorrow you have the class at the same time.
చెప్పండి.
సార్ 10కి తీసుకోండి సార్. మార్నింగ్ చాలా
ఈ ల్యాప్టాప్లో ఏంటంటేనమ్మా స్క్రీన్ మీ మైక్స్ అన్ని మ్యూట్ చేయండి.
మీ మైక్స్ అన్ని మ్యూట్ చేయండి.
I'm stopping this meeting. Okay, we will meet you tomorrow. I will send the document, go through it.